So, because the cell membrane is so tightly packed with those phospholipids, a molecule that's this big could easily just squeeze its way on through, right? But a molecule that's that big is going to get rejected. All right, it's going to get bounced right back. The cell membrane is going to say, no way, you're not fitting through here, fatty. All right, maybe there's a chance that it can fit through a channel, all right, fit through a back door of one of those proteins. We'll have to wait and see. Ultimately, the whole reason that stuff moves back and forth across the cell membrane is that it's trying to maintain homeostasis. Right? It's trying to maintain that constant level. Right? If your cells get too hot, they push warm water out, you start to sweat, right? Release some of that hot liquid so that your body temperature remains constant and you can cool off. Cool 98.6. If your body has been using lots of water or losing lots of water, you become dehydrated, you get thirsty, you drink. That water needs to get inside of your cells so that you can rehydrate and maintain homeostasis, a good water balance. All right? pH levels. Your stomach needs to be acidic, but your mouth doesn't, right? There are different levels of all different things. Ions. Remember when we did the Gatorade demonstration? We talked about the nervous system, right? Nerves operate very much like electricity. Ions are needed for the nervous system to work properly. Different types of ions help the nervous system work right. So we have two different types of cellular transport. We've got passive transport and we've got active transport. The word passive, a passive person, kind of implies like calm, laid back, chill, relax. All right? I like to think of passive as being go with the flow. All right? Passive transport is go with the flow transport. Whereas active, an active person is like go, 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 right? Non-stop. Active transport is going to be like super energetic, really, really hyper, going all the time, right? So passive transport, you're just kind of chill, you're going with it. Active means like you're really pursuing it, you're going for it. So, when we talk about passive transport, we take that word literally. Passive transport requires absolutely no energy for the movement to occur. If there's no energy needed to make it move, then why does it move? There's a concentration gradient. There's a difference in concentration gradient. When we say gradient, right, I'm talking like scale, like the color intensity scale for the enzyme lab, the stain intensity scale. Remember the differences in shading? A gradient, like differences, levels. There's differences in concentration of a substance, right? If you have a high concentration and you have a low concentration and there's a semi-permeable layer between them, if you're not putting energy in, which way are you going to want to flow? High to low. You want to just roll downhill, go with the flow, right? You want to just move down the concentration gradient. You want to move from high to low. That's passive transport. Passive transport is movement from high concentration to low concentration without any energy. All right, so the concentration gradient is the difference in the distribution of the substances across the space. How concentrated is it? How much stuff is there in that one little area? Is it really, really crowded, or is it not so crowded? All right, and when it moves, it's probably going to move from a really crowded area to a less crowded area. It wants to spread out, right? Because the natural flow, it wants to space itself out and get some distance. Active transport, on the other side, requires energy, right? You got to put energy in. Put that ATP, adenosine triphosphate, the energy molecule of your cells, of your body. You need to put that energy in to make the movement occur. Right? In this case, movement is going against the concentration gradient. Well, before we said that movement would occur from high concentration to low concentration. If it's moving against the gradient, that means it's going from low to high, uphill. I don't know about you guys, but uphill to me, that requires some energy. All right, moving uphill requires some input of energy to kind of generate the movement and force it in that direction. All right, so again, because the molecules are moving, all right, from low to high concentration, energy is going to be needed to actually push them up the hill.